Um, Java 9 has a shell, which means that we can actually type stuff and see it immediately, right? And interface, the idea, you were asking interfaces and maps. So let's go over them quickly, and feel free to ask questions. The idea of an interface is to define operations and not care about how they're implemented. When you are the client, when you are the user of a class, right? You, for the most part, don't care how it's implemented. You have a point, you call operations on it. You have a list, you call add. Do you care how it's implemented? Slightly for performance reasons and things like that, but normally you don't terribly care. Does that idea make sense?
I mean, implemented in the end product.
Actually, like, imagine that I do this, right? List of string words. No. Okay. So is it size, or is it that you cannot see the bottom? But what was the problem?
The words were all the way.
Okay, so it's not that the letters are too small.
Yeah.
So I just cannot.
Below the screen.
Yeah, that's it. This works. I created a list, right? It's a list of strings, and because it is a list, I can do things to it. Words.add hola. I can add it, right? I can do words.isEmpty. Now, do I know what's the implementation, right, of that array list? Do I know how they implemented it? No. Do I care? Not terribly, right? Sometimes I do, but for the most part, I don't, right? All I care about is the interface, the methods that I can call, right? All I care about is that I can call add, get, isEmpty, and size, right? There's a bunch of other methods, right? Does that idea make sense? In fact, it could happen that instead of creating a new array list, I create a new vector. It's a different class, a different implementation. It's a different actual code that gets executed when I do this. On the other hand, I don't terribly care. I call add, the thing gets added, right? Once I add it, if I do words.get of 0, I'm gonna get what? Hola. And I don't give a hoot how it's implemented. Does that make sense? The idea of an interface, Java lets me define something with a name and define all the methods that it supports. And then I can have different implementations. So in this case, the interface is called list. And I can have different implementations. I can have array list. I can have vector. Java actually has a couple of other implementations. And my code doesn't change as long as I use the interface. As long as I define my stuff with the interface instead of the implementation, then I can later on change the implementation and it all works. Does that idea make sense? I can define interfaces. interface. I called it stuffer, and it has one method, do stuff. And I could define a class or 17, right? I need to say implement this interface. And then I could come here and define those things. On the interface, I don't need to say public because it doesn't make sense to define any private methods, at least up until Java 8. Let's do it simple, right? All the methods are what the client is going to call. So they are all public. So I can declare do stuff, takes no parameters, and I will do system.out.println doing stuff. Didn't work. I forgot to put void. And given that I'm using this as an interpreter, I'm writing my stuff in a horrible way rather than nicely, because this way I don't have to type that many lines. It's a pain to edit when you have many lines, right? What this allows me to do, right, is to have stuffer s equals new my stuffer. I can call s.do stuff. I could define other things, right? Instead of this, I can define my stuffer 2. Now it does do stuff 2, and so I could do, right? Now S is a new stuffer 2 instead of a new stuffer. So if I call do stuff, it's going to do doing stuff 2 because it is a stuffer 2. This is called polymorphism, and it's awesome, right? For the assignment, one of the assignments was it 8, maybe, right? We had an interface for a math problem about, right? For shapes, right? For like a elementary school things. If you remember, they tortured you in elementary school with calculating the area and the perimeter of different figures, right? So what we had is an interface, right, that defined 3 methods: get area, get perimeter, and get nice representation or something like that, right? For problem statement or something like that, right? And so what you need to define is your classes that define those 3 methods. All you need to say is my class whatever implements this thing, and then all of the other stuff just works. If you use the interface, it works. I could do stuff like list of stuffer and doesn't work. Return type required. Okay, let me do this. Oh, I think it just works like this, hopefully. Okay, never mind. Add them the ugly way. There is a nice syntax for doing this, but I cannot remember. Oh, list is abstract and cannot be instantiated. Okay, hash list, or sorry, array list, right? Mew, Mewtwo, Pikachu. I can add a bunch of this and then add. SS is a list. It has 3 guys, right? I can do 4 stuffer as it goes through every element in the list, right? And calls do stuff. And depending on the actual type is the method that gets called. This is polymorphism. It is amazing. I could have different kinds of things in my program, right? And I just call the same method. If I have a game, then I could have players and NPCs, right? Monsters, those kinds of things. And I can call the move method on them and move them. And I don't terribly care what the heck it is, right? Maybe the player, maybe an enemy, maybe a monster, maybe something that you eat, right? Something that you eat is not the right way, right? Something that you collect to gain points or something like that, right? But I can just call the same methods on it if I define my interface, right?
It's funny you typed Mew. I watched a tutorial where it was it was kind of like he made a game sort of like Pokemon, but it was different monsters, and it didn't matter what monster you used. If you called .attack, it would do whatever that monster's attack was.
Exactly.
It was pretty cool.
And so you can do whatever, right? The point is you define the interface, and that's the externally accessible things, right? This is my facade. This is what you see. And you don't give a hoot what's going on behind it. But what we are doing is kind of halfway, right? We are both defining the interface and defining what goes on behind it, right? But that allows us to have arrays and lists of things and not care what they are on the generic code, on the code where I'm going to the list. I don't care whether it's a square or a rectangle or a circle. I just call get area. And then. Does that idea make sense? Does the syntax make sense? It's very similar to a class, right? Just use interface, and I don't have method definitions. I just have semicolons. And since everything's public, I don't do public. Or static. I cannot do static on an interface. Java 8 added more stuff, but...
So can you do scripting on the shell like that?
Yes. Don't, but you can.
Probably
If you want to use Java for scripting, don't. Use Groovy. Groovy is a lot nicer for scripting.
I've used Python before, but I never understood why it would run in the terminal in Java.
They didn't. It's one of those things, right? To me, having a REPL is amazingly cool, right? Eclipse is really nice, but I would much rather have this so I can type things and see immediately what's going on, right? Java and a bunch of other languages didn't have that. Java has the added problem that you're not supposed to be able to do this. You need your classes and your main class and things like that. So who knows? So they took their own sweet time to define what the heck does it mean for me to actually this, right? Which class does this live in? So So they finally came up with what they're doing. But way before Java, a bunch of other languages use the JVM. Java, the language, kind of sucks because they defined it in 95. It was amazing for 95, but there have been 20 years, right, of more amazing stuff. However, Java has to still work like 95 or 93 or whenever it was defined, because now you have a gajillion programs written in Java. And so if they change it, it breaks all those programs and people get really mad. So they have kept ugliness, right? Plus, you different languages find different balance of features and things like that. At some point in time, Groovy started as a scripting for Java, but then became its own language. And for scripting, you want more dynamic typing. You don't really want to declare your types, and which doesn't go well with Java's philosophy, but it goes. So if you want to play with scripting, do Ruby. Or Groovy, sorry. Or Ruby or Python or those guys. But this allows you to have a REPL in Java, which is amazing. You guys, sorry, it didn't come in time for you guys. It's Java 9, it's not even officially out. But if I teach this class in fall, I'll be using this, but I can't quite use it for you guys.
When do they add it to the repositories for app-get? Just a curious question. Because like if I do app-get on mine, I think it still gets
Oh, Ubuntu? I have no clue. In fact, this is not, I just downloaded it from Sun, from Oracle. Yeah, many times Ubuntu will keep some. Once you get deeply into a particular thing, then you normally don't use Ubuntu's packages because they are not up to date.
Yeah.
They're never up to date enough.
For almost everything I've tried.
Yeah. So
Eclipse and Java, it's the same way.
yeah. Yeah. One cool thing about Java is that Java is its own JVM. So like Eclipse, you just download a zip file and unzip it, and that's it. There is no magic.
Yeah.
Because it runs in Java, so you just need Java, and then everything else goes from there. But anyway, so this is the idea of interfaces. You're cool. You understand them. You understand what's the point. Many times as a programmer, and we're talking about this, right? Computer science is kind of a mix, and software engineering, or whatever the heck you want to call what we are doing. It's kind of a mix of math and philosophy. You're defining your own language. You're defining your own world. So you, as a software developer, need to come up with your interfaces, right, that define concepts in the world. So this really philosophy. I'm going to model my shape, right? And I only care about these things about my shape, right? So if I have a store, I'm only going to care about these 5 things about my products. I only care about their title, their price, their weight, and that's it. I don't care about anything else, right? So you are kind of defining the world, which is more philosophy than anything else. And defining interfaces, right, becomes, here's my definition of the world. Here's what a product is, and here's the things that it has to support. Has to have a get title method and a get price method and things like that. And then you can go from there. So this is actually the hardest part and the coolest part of computer science. But, now, a lot of the things that we do and a lot of the things that you end up doing throughout is defining more complicated interfaces for computer science stuff, right? Normally, your computer science professors don't know anything about stores because they don't manage stores, right? Or productive processes or any of those things, right? So we tend to define our own abstractions over the stuff that we deal with. So we have really cool list abstractions. We don't have really cool product abstractions because we don't know how to deal with products. The list is an abstraction over the idea of an array, right? You have a bunch of things. The other abstraction is the map, and they're both kind of offshoots of arrays. In an array, I have a bunch of things, right? In an array, I number those things from 0 to n, and I can access them as the thing at place 3, right? That's my index in the array, right? I cannot have holes. I cannot have an array that has things at element 0 and 1 and then 17 and 19, right? I have all of them. They may be null, but I have all of them, right? And my indices have to be integers, and that allows me to go through every element in the array. That allows me to go through every index in the array because they are the numbers from 0 to 19. And so to every element in the array. A list is like that, except that I can grow it and shrink it. So it adds the add method and the remove method. A map is a different offshoot of an array, and it says, what about if my indices are not integers from 0 through 19, but they are strings? So I can define map of string to integer student ages equals new. And again, the interface is the map. So I defined a map. The keys are strings and the values are integers. So it's kind of reversed. So I can say student ages dot put. I'm not going to use any of your ages. Go 25. And then is 23. It's hard for me to go through every element in here. We'll see that you can, but because, right, I don't know what are all the strings. I cannot have every string, so I have holes. What I can do, student ages dot get of Joe, and I get 25, which is what I put in here.
So the game reviews, were we supposed to come up with a name of the game?
Actually, you were building, right, for the assignment. You are building what I am calling. So in order for you to test, you can. You don't need to. I am calling you and I'm giving you the name of the game, right? In this case, kind of you're doing the reverse. You are building a piece that's going to be used in something bigger.
So I was getting confused with this put method here about what exactly to add in the parameter.
The first thing is the key. The second thing is the value. So I could do, for example, map of string to stuffer. What I put here is, this is my key. This is my value. So I can do stuffs dot get. This is my key. I get my stuffer. I don't. And I could do dot do stuff. Does this make sense? So for the assignment, you'll be putting game infos as your values, right? And the title of the game as your key, right? And so they're either just call the method on the game info, right? Then the first one where you put it, right, where you add a review is, oh, let me go see, right? I call get to get that review, to get that game info, but it may not exist. So I need to use contains key rather than get, right? So if I call stuff.contains key as one, I would get true. Stuffs. And then as 2, I would get false because it doesn't contain it, right? So you can see, do I already have a game info for this game? If I do, just add the review to that game info, right? And then have an add review method for the game info, so I just call it. If I don't, then I create a new game info and stick it in there. And then add the review, or add the review and then stick it in there. And the other ones are just get the game info for this game and then call the appropriate method. So are you all cool with what maps are? Reasonably cool.
It's actually it was kind of hard to find tutorials online that explained it. Yeah, that would explain it well. For me.
That's why you come to class, man.
Yeah.
Yeah, many times, to tell you the truth, one of the things that I really like about classes is that you can ask, right? Tutorials, it's kind of hard to ask questions of a video, right? They usually don't answer. And so many times you find tutorials, but they're not the right ones for you, and it's hard to know until you watch them.
Yeah.
And I never got around to make one for maps, like a 2-minute tutorial. I did one for lists, right? Was mildly useful. But yeah, other things you can actually do stuff dot values, get values. No. Keys?
Just not get it.
Well, dot get gets you one thing, so it's keys. Oh, key set. That gives you a list of all the keys. And you can call value something, values. And that gives you a list of all the values. And then entry set gives you actual pairs of key and value. So you could iterate through all the elements of a map, thinking of them now not as a quick way of finding the key, but going through all the keys and all the values together. let me just prime your brain since we are here. Maps are one of the coolest things that you will study in data structures, which is kind of the next class, because we use a bunch of data structures to implement them. For array lists, for lists, you'd normally study linked lists, but the obvious implementation is just an array. And all you do is grow the array. You cannot grow the array, but you can create a new array, copy the elements, right? And that's it. For maps, you have two different things, and it also shows you kind of different kinds of timing. You could implement a map as just a list of all the keys and values, right? Kind of an array of all the keys and values, if you want to think about it that way. Problem is that finding something is going to take you forever because you need to go through every element in the array, right? We normally use trees, binary trees, or other kinds of trees, and that gets us, instead of linear time, gets us logarithmic time, because we divide by half. And then many times we use hash tables, which is kind of the default. And hash tables are magical and get you almost constant time at the cost of wasting some space. But they get you expected constant time for finding stuff. They are incredibly cool wizardry that you will see in data structures.
Is it similar to like a node, I guess, like in C++, like a pointer with a data value?
Well, it's a node for what? In C++, you probably saw nodes for linked lists.
Yeah.
And have one pointer. You can have for trees, they have 2 pointers.
Yeah.
And then hash tables are other kind of wizardry that you may or may not see. Unfortunately, we kind of went from trees are amazing, and trees are amazing, to, oh, hash tables. In the beginning, we thought that hash tables weren't that good. And now we have kind of made them so they are even more amazing than trees. Except when they're not. They're different.
I guess we have like the technology for the space now. If the hash table takes up more space.
The problem with hash tables wasn't so much space as the fact that when it fills up, you had to rebuild it. And that would take forever. And so a hash table worked constant time, except when it overflowed. And then you had to do horrible things too. And so you would add things and it would take a second, then 5 minutes, which makes them horrible. But we found better ways of doing that, better algorithms for doing that. So now they're still the same kind of stuff, but not as horrible. Are we cool with trees and all those things? Java has a bunch of other collections that we didn't really get into because there is no time. So it has sets and queues and double-ended queues and priority queues and a bunch of other things. When you have chance, go play with them, but not in this class. Life sucks. Okay. Now,
Is the final exam, it's not next Monday, is it?
no way.
Okay.
Actually, we still have 2 more Mondays.
Yeah. Oh, we're having it on the exam date.
Wait. The final exam is whenever Kennesaw says the final exam is.
Okay.
But the last day of classes is 2 weeks from today. So we still have 2 weeks, and then whenever is the final exam. It's a reminder that I need to go find out when is the final exam. But this is not the page you're looking for. Yeah, so we can talk a little bit about exceptions. And many times when we try to do stuff, we find an exception. We find that something didn't go as we planned, right? For example, right, sometimes it's because the user is dumb, right? I have stuff, so I can do stuff.get s1, and the map can helpfully tell me, right? That's the software. I can do stuff, and it would do stuff, right? Now, what happens if I do this? S2 instead of S1. Do I have a value for S2? No. Then what should the map return? It just doesn't know, right? But it actually returns no. Cool. Or if I have an array, right? And I get, in this case, it actually generates an exception, right? Like, okay, I have 5 elements. You ask me for element number 6, which is actually 2 passed, right? Even 5 would be bad. So there is nothing that I can do. There is no reasonable answer that I can give you. We could, for many of these things, come up with, okay, how about we make this thing return you an object with 2 things, true or something that's true or false for whether we could find the element, and then the element, right? Or things like that. But it becomes really, really ugly, right? Does that idea make sense? It becomes also ugly because many times we don't know what could go wrong. If I try to read from a file, what could happen? The hard drive crashed. Or the file was in a USB drive and the user just yanked it. Stuff went bad, right? So exceptions are one mechanism for dealing with stuff happens. They shouldn't be for normal error conditions, right? If you know what you're doing, you can generate a nice error message, you know how to deal with the errors, then you should deal with them. Exceptions are kind of a last resort of, I have no clue what to do with this. So I'll just throw this exception into the air. We can throw, okay. We have an exception class. E is an exception. I can normally create my exceptions with a type and a string description, right? Exception is kind of a not very descriptive type. It's just bad stuff happened. I can create better types describing this stuff. What can I do with an exception? I can throw it. Or throw new. The exception will go up if somebody called a function that calls a function that calls a function. The exception will go up until somebody says, I can deal with it, or until it reaches the top level, and then the JVM will print a message and die. Or in this case, right, we have a top level thing in the interpreter that prints a message and doesn't die, just goes to the next thing.
Is it acceptable to use an exception in like a case, or to create an exception in like a case, like if you want the user to be able to terminate the program, like hit escape, and just say program aborted instead of throwing an exception like something not finished? Is that? I guess it's not usually done.
That's probably not good practice, right? Now, when something has to ship on Friday, would I do that? Maybe, but I wouldn't consider that good practice, right? Exceptions should be for bad stuff happened, as opposed to regular. That should be built into the program, as opposed to. But.
I used it as opposed to trying to get the unit code for escape and test if escape was pressed or something. It was a lot more. It was a lot easier just to define an exception that just say program aborted. It's okay.
When something has to work and you have a deadline, then working is the most desirable quality on code, right? Then you should make it understandable. But if not, working is better than not working. Now, how do I catch those exceptions, right? You can do try. And a catch. Oops. Oh, probably should have semicolon. Print stack trace is a nice method for the exception class that prints the whole thing, right? So this is all that was happening. In this case, it's not very useful because all that is happening is in the repo. It's in the interpreter. But, the cool thing is I can say, I'm going to catch this guy, right? So if something bad happens of this class, then catch it and do something with it. It has to be of that class. If I threw a throwable that is not, that's kind of an interface that's above the exception class, and so I don't actually catch it. Go back to the essential. At the top, we have the throwable interface. Then we have the exception class and a bunch of subclasses. And we actually have runtime exception, which is also useful. The exception class has 1,700 other standard exception classes. You can kind of figure out where should you be using these, or come up with your own exception classes and things like that. User exception. That's still Corba. I don't see any good exception classes other than this. Now, a couple of other things. We can actually have also a finally. clause. And the finally clause gets done regardless. Whether I threw an exception or not. The thing that goes after finally always gets done. Does that idea make sense? Some sense. And you'll probably practice a few more of these. I'll come up with an assignment, Politician's Promise. And so you will practice a few. A lot of this will come with practice, and so you'll probably have to do this a million more times. The assignment is just a tiny bit of practice. You probably will be using this a lot more throughout your career, but Java forces you to declare that you throw exceptions when you do, and to catch those exceptions. So I can define void, or let's say int divide, I could just do, right, return A divided by B, right? Well, what happens if you divide 1 over 2, 1 comma 2, gets me 0, okay, 4 over 2, I'm doing integer division, right? Now what happens if I do this? Bad stuff, right? So what if I want to declare my own exception? If B is 0, throw and it's going to tell me, you need to tell me that you throw an exception because you're throwing it. The compiler is not going to let me. So I need to say throws. Now I have throws exception. Now, if I call divide 3, 4, in this case, it will let me. Java normally will not let me because it's throwing an exception and I'm not catching it. So in a normal method, the interpreter does magic for me. A normal method, I need to do a try catch. It will force me in Eclipse to do a try catch. That's kind of, well, this guy said that this can happen. Now you have to deal with how it happens. What I could say is I also throw the same exception and I let my parent handle it, whoever called me handle it. Except for runtime exception. Runtime exception is special and you don't have to catch them. So that's how they cheat with arithmetic exception, right? Which is what it threw. What was this? This guy is a subclass of runtime exception. And so it doesn't have to be called. Doesn't have to be declared or catched or anything like that.
So it basically just replaces the error that the compiler would output with your own custom error.
It's not the compiler. This is when you run it.
Oh.
This is at runtime.
Oh.
But the compiler will complain if you call a function that's supposed to throw an exception and you don't catch it. Because that means that you messed up. Let me actually was supposed to be IO, but oh well. Let's change and use full Eclipse. If I declare then here I cannot do I try to compile this, it will tell me unhandle exception. I need to declare, I need to do something with it. I can cheat, maybe. I don't know if now that's a main or there is no main. Oh, it works. So that's a common way of cheating, but I need to do something with it, either throw it or do a try catch, right? Either declare that I throw it or do try. I don't need to do anything with it, I just need to catch it. So the compiler forces me to be disciplined. This is bondage and masochism. But it is so that I cannot inadvertently mess up. I still can mess up. I still can mess up many, many, many ways, but it protects me from some of them, right? Just like typing. And this is a good seg into the next thingy, which is file IO. Many times we want to read and write from files, right? In Java, we have several things for dealing with files. First of all, we have this kind of even more abstract concept of stream. A stream, well, reading an input stream is something that I can read from, that I can read data from. And an output stream is something that I can write data to, right? What can I read from an input stream? The most basic thing. I can read a byte. And then I can read another byte. And then I can read another byte. And then I'll figure out what those bytes mean on my own. Does that idea make sense? Now, how is this more abstract than a file, right? A file on disk. What is a file on disk? You have a text file, when you have your .java files. What are those things? They're just a bunch of bytes, right? Associated with a name. That's all they are. But there is one level of abstraction up, in that a stream doesn't necessarily have to correspond to a file. The keyboard is sending data. So I can read from the keyboard, and it's a stream. And I use the exact same thing that I used to read from a file. I can read from a socket, from a network socket, establish a connection to a server, and the reading is a stream. It's an input stream. I can read stuff to it. So a stream is a more generic concept of stuff that I can read to. Well, input stream are stuff that I can read to. Output streams are stuff that I can write to. Files actually are called random access things because they actually allow me to move within the file. On a stream, on something like the keyboard, I can only read the next byte, and that's it. On a file, I can skip 10 bytes. Many times you get byte streams. And basically all you can do from them is read a byte. You can actually read a bunch of bytes. Actually, not even read a bunch of bytes. You can only read a byte. We create an input stream like this. This would be a file input stream, so we are reading from a file. Reading actually can throw I/O exception because bad stuff can happen. So we need to put everything inside a try catch. Well, in this case, there is no catch. We don't do anything. We just do a finally. And this will open a file for reading, a file input stream for this file, open a file for output, and then keep reading. The read operation returns -1 if it couldn't read. And so if it returns a positive value, it's a byte, and if not, it's -1. Which either means bad stuff happened or I read the last character already. And this is one passed. Does that make sense? We normally don't do this because this is horrible. Oops. So we normally don't deal with byte streams. We tend to read with character streams where we are reading text. Actually, we normally want to deal with buffered streams that allow us to read a whole line or something like that. And to tell you the truth, we want to deal with readers and writers, which are this, which is what we have been doing, right? Scanner, this is what you have been doing. Now we need to create those things. Scanner S. This. So I can do file. What's that? File input string, right? So this. I can use a file reader, and then on top of it, I create a buffered reader. So I can do buffered. You know what's going to happen, right? Oops, that guy doesn't exist. Oh, well, actually, first I'm doing something bad, regardless of that. Oh, because this was reader. That guy doesn't happen, right? For the most part, you will use readers because we are going to be reading strings. You can read byte by byte and define binary protocols. I'm going to write 2 bytes that represent an int and then another 4 bytes that represent a float. It is just horrible. So for an intro class, you definitely will not do that. It's not. You can do it. It's just painfully. You have to pay attention to detail. And you cannot see what happens, right? Because it's binary. When you're dealing with text, it's a lot easier. In this case, there is no stuff.txt file. Actually, open another tab, go home, and then send stuff into stuff.txt. Now I can open home/stuff.txt. And that guy should exist. Oops. No. What happened? Home. And there is stuff.txt. Okay. Java doesn't know tildes. That's bash. Oops. Sorry. There is no naming convention for how to name files. Your operating system will force you to name things in different ways, right? I'm in Linux, so that's usually have it. So I can do read line. That's giving me strings until I get nothing, and then I can ask r dot that's what you normally do. I can file. Ready? For a file, right, when I do ready is false, that means I cannot read anymore. I can do reset, that will reset it. Oh, but I cannot mark. Okay, I can recreate it. Haha. Yes, ready, it will tell me true because I can read. Then it's back at the beginning of the file, right? I can do read line, or I can do oops. With a scanner, I can do next line or stuff like next int and things like that. Let me go overwrite this thing. Oh. Redo this, because if not, who knows what the heck it's going to read. Int gets me a 1, right? And if you remember, we did this stuff at the beginning of the semester, right? When you were reading stuff from the keyboard. The only thing is that now you need to wrap this into a try catch, because since you're reading from a file, you can get IO exception. And at the end, you are supposed to do close, and that closes the file so you could read it again or things like that. As far as your program is concerned, the file is still there. If you are writing to a file, you get a writer rather than a reader, and it's the same thing, or fairly similar. Does this idea make sense? And then this becomes mildly complicated because you build stuff on top of this, right? So on top of this, you say, okay, now imagine that I'm reading a square, right? I want to create squares. So what am I going to read? Well, or I'm going to read shapes for a program that calculates stuff from shapes. So I need to define my protocol. What am I going to read first? Maybe I'll print, you have to put the name of the class, right? And then a bunch of doubles for the parameters, right? And then a new line, and then the next shape or something like that. So you build your protocols based on strings. Some cool things. No, they don't. Never mind. Never mind. They don't define any useful stuff. Most of the, although this is, yeah. Most of the languages give you a way to just go through all the elements, all the strings in an array as if it was a list or something like that. That's when you're dealing with them as text. That's very convenient. Once you start defining the shape of your file or the protocol, then it's not as convenient. We will only deal with reading text from files. But just so you know, there is a couple of other interesting things that you want to know besides reading and writing text from files. You could do binary protocols. They are a pain in the neck. Java gives you kind of basic serialization. Basically defines automatically how to write an object and read an object. So you can just read an object write an object in binary, and later on read a whole object from the file. The exact same representation in memory, and you don't care how it was written or read, right? How it's actually represented. So that's called serialization. And that Java gives you that for free if you want to. The other thing that we tend to do, and Java doesn't quite give it to you for free, but there's many libraries that will do, is write it as JSON or something like that. The problem with serializing your stuff in Java is that you can only read it from Java. And so if you're sending it over the network, who knows what's on the other side, right? Eventually, it's the program that reads the data also a Java program. And so we used to define, and we still do define, bunches of binary protocols like protocol buffers and things like that to do it in binary. But we have all more or less agreed that we want to keep it in text and use JSON. 10 years ago, we had all more or less agreed that we wanted to keep it in text and use XML. Now everybody prefers to use JSON, but so that's just a text representation of the same thing. In real life, you will have a library that you can call and that reads a JSON object and maps from that string into your Java object, or that writes it from your Java object to a string, which is the common thing, but we are not covering that here. You will actually have to read strings of text from a file. And that is it. Probably the most important thing is to realize that the stream abstraction, right, that you have already been using, you have been writing to stuff, the screen, and you have been reading from stuff, the keyboard, it's almost the exact same thing when reading and writing from files, with the added thing that you have to deal with I/O exceptions. You normally don't deal with I/O exceptions from screen and keyboard. I don't know if I don't think, they don't count it as it can happen anymore. Any questions? Any answers? No. Then I'll see you guys in a week and I'll post an easy assignment about dealing with files.
Will that be the last assignment?
That
Probably an exam review.
maybe,
Yeah.
no,
Exam review.
no.
No exam review?
That's no assignment for exam review.
Oh,
Yeah, maybe. I really wanted to. We'll see. I'll probably do kind of a combination.
And the final will be like the midterm, I guess, basically.
The final would be like the midterm, except with all this other stuff, except with classes and things like that. Yes, except with double the fun. Let's stop this guy.